In my last video, I built a full multi-agent coding workflow in OpenCode. Planner, debater, implementor, reviewer, tester, linter, and a commit message generator. All sharing context through one workflow file. But every agent was using GitHub Copilot models. Today I'm replacing all of that with Ollama. Fully local, zero API cost, complete privacy. Plus, I'm adding a security expert agent and a tool called Serena that gives your agents real semantic understanding of your codebase. Let me start with Ollama, because if you haven't used it before, this part matters. Ollama is a tool that lets you download and run large language models directly on your own machine. Think of it like a local model server. You install it once, pull whatever model you want, and from that point on, you have an AI running entirely on your CPU or GPU. No internet required after the initial download. The reason this matters is privacy. When you run a model through Ollama, your code never leaves your computer. It's not sent to any API, it's not logged, you don't pay per token. If you work with sensitive code, work under an NDA, or just don't want your work training someone else's model, Ollama solves that. Ollama has a library of dozens of models. Llama from Meta, qwen from Alibaba, DeepSeek, Mistral, Gemma, and more. You pick what fits your hardware and your task. And this is the part I will come back to in a few minutes. Ollama also has cloud models, which give you a flexible mix. Sensitive work stays local, heavier tasks can go to a stronger cloud model when you need it. So that's the idea. A local AI model server on your machine running whatever model you choose. Now let's look at how to actually find and download a model. Go to ollama.com and click on the model on top. This is the full catalog of models you can pull locally. Here's how to read this page. Each model has a name, a description, and a set of capability tags like tools, vision, or embedding, or code, and a list of parameters sizes you can choose from. Parameter size is basically how capable and how heavy the model is. 3B means 3 billion parameters. Fast, light, small file. 8B means 8 billion parameters. For this workflow, I'm going to use two models. Let me show you both. First, Gemma 4 from Google. This is what I use for the planner and implementor, the agents that do the heaviest thinking and the actual code writing. Notice the tags here. It supports tools, which means it can call functions in agentic mode. That's important because not every model supports this. The 26 billion version for planner and implementor, and 4 billion version for the linter and commit message agent. These agents only need to run a linter script and read git diff. So a small model that can do the job is the right choice. Second one is qwen 3.6 from Alibaba. This is my preferred model for all the support agents: debater, reviewer, security reviewer, and tester. The 27 billion version is good. My system does not support a heavier version. Pulling a model is a single terminal command. Let's do it live. Type Ollama pull, and then I copy the model name. First I download the Gemma 4. You will see a download progress bar. The 26 billion version is about 18 gigabytes. The 4 billion version is around 10 gigabytes. It downloads once, lives on your machine, and never needs to be downloaded again unless you update it. And let's download the smaller version for linter and commit message. Welcome back to Ollama models. and search for qwen 3.6 and use the 27p version. Once they are downloaded, check what you have with Ollama list. Now let me do a quick test to make sure it's actually working. Takes a bit time. I'm gonna send a simple message. It's actually fast. A note on hardware. The 27 billion models work well on a machine with more than 32 GB of RAM. If you don't have a dedicated GPU with 16 GB, you can still run them. With the GPU, NVIDIA or Apple Silicon, they will be much faster. If you are on older hardware, stick to the smaller models across the board. The workflow will still run. Output quality will be lower, but the structure and permissions work exactly the same. Now here's the part that makes Ollama really interesting for agentic workflows. Cloud models. Any model with a cloud tag on Ollama uses Ollama's infrastructure. The big advantage is reliable tool calling in agentic mode. Fully local models can be inconsistent, especially smaller ones. The trade-off is that cloud models use your daily Ollama token budget. My recommendation: use cloud models only for planner. This agent needs reliable tool calling. All the other legends, debater, implementer, reviewer, and so on, run fully locally. That keeps our cloud token budget for the tasks that actually need it. And if you are working with truly sensitive code and need everything locally, remove the cloud suffix everywhere. Use fully local models across the board. The workflow still runs. Privacy guarantee is absolute. Alright, let's wire this into OpenCode. OpenCode is configured through a file called opencode.json. You can put this in the root of your project for project-specific settings or in your global config folder if you want it to apply everywhere. For this workflow, I will put it in the project root. But before jumping to the config file, let me show you something. Go to the OpenCode website, go to the documentation, and then providers section. Here you can see a list of providers that OpenCode supports. I'm gonna scroll down and look for Ollama. Here you can see that how OpenCode is going to use local models through Ollama. In order to do that, I need to install AI SDK. If you go back to the top, the overview, you can see that they also mentioned here. So OpenCode use AI SDK and models.dev. And for the AI SDK, it's pretty much easy. So just run this command in your machine and then install. Let's define Ollama as a provider in OpenCode. I start with adding a schema. And then I need to add a new provider. The provider name is Ollama. I need to give a name to my Ollama provider. I'm just gonna call it Ollama local. The next step is I need to use that npm command that I showed you in the OpenCode documentation. And then I need to define the options, which is the base URL and the address where I hosted my local models. So I do that locally, and therefore I'm calling a localhost. And then I need to define the models. I start with Gemma 4. And then a name for this local model. This is it. You can define your own models, the downloaded one. Just use the model name here and that's it. I configured the rest of the models. One thing to note here, the base URL. Ollama runs a local API server on this port that speaks the same format as OpenAI's API. OpenCode can talk to any OpenAI compatible endpoint, so this just works. And also you can see that I changed the local host to a local IP address. I configured Ollama to be visible in my local network, so I can have access to my local models from other computers in my local network. Now let's change each agent model. This is the key part. Instead of each agent using the same global default, each agent gets the right model for its job. So I'm going to use Gemma 4 26 billion version for planner and implementer. For the linter, I'm going to use the E4 billion version, and for the commit message as well. And for the rest of the flow, I'm going to use qwen 3.6. The temperature values are intentional. Tester, linter, and reviewer stay at the lowest temperature because I want predictable and consistent output every time. The debater gets higher because I want it to actually challenge the plan. A little unpredictability here is useful. Here's what the planner looks like from the previous video. I'm changing exactly one line, the model. I'm also adding security reviewer to the task allow list because the planner needs to be able to hand off to the security reviewer later in the workflow. That's the model swap done. All behavior, all prompts, all permissions stay exactly the same. Let's add the two bonus features. First bonus, Serena. This is optional, but once I use it, I stop wanting to go back. Serena is an MCP server built for coding agents. MCP stands for Model Context Protocol. It is a standard that lets AI tools connect to the external server, that expose new capabilities. What Serena gives your agent is semantic understanding of your codebase, not just text reading. Without Serena, your agents find code by reading files and using grep. They open a file, read the text, and guess from there. With Serena, they can query your codebase by symbol, find every call site of a function, understand class hierarchies, trace where a variable comes from, like an IDE, not a text editor. Adding Serena to OpenCode means adding it to the MCP section of OpenCode.json file. This should be alongside of the provider. So I define new MCP block. Serena is my MCP name. It's local, and I just use UVX to run Serena. This tells OpenCode to start Serena as a local process using UVX, which is the Python runner that comes with UV. If you don't have UV yet, install it first. It's a one-liner. Once this config is in place and enabled, OpenCode connects to Serena automatically on startup, and Serena's tools are available to all your agents. But just because Serena is connected doesn't mean agent will use it. I have to tell them to. The best place for this is agent.md file, the shared rules file that every agent reads. This one block in agent.md file means every agent in the workflow inherits this rule. They know Serena is the preferred tool for navigating code, not single file reading. You can also add Serena specific instruction inside the planner, implementer, and reviewer if you want more control over exactly when and how they use it. Second bonus, the security reviewer. The idea is simple. After the regular reviewer checks your code for correctness, a dedicated security reviewer checks it for security issues. Two completely different lenses on the same change. And the key design constraint. The security reviewer is strictly read-only on your application code. It cannot edit files. It can only update and report what it found into the workflow state. This is intentional. The security auditor should never silently modify your code. It reports, and the implementer will fix it. Let me create the security reviewer from scratch so you can see exactly what goes into it. I need a description for my new agent. Then I'm going to define the mode, which is sub-agent, and then we need to define the model. I'm gonna use qwen 3.6 for security reviewer, and then temperature. Gonna talk about it in a minute. Notice the permission block. Edit is denied for everything, except workflow state file. That's the whole point. This agent can read any file in the project, but can only write to the workflow state file. It is physically incapable of touching your code. Now the prompt body, I'll be specific about what to check, because vague prompts produce vague security reviews. You can customize this part for your project. For my project, I think these are enough, but in the future I will try to improve this part for my project. But you can decide. So for example, here you can mention missing input validation. If you're working on an API, here I also mentioned Serena, because now I added Serena as an MCP to my agents, so I can use Serena whenever it's possible. The next step, I need to add a new section to the workflow state, because I want the security reviewer to add its finding to the workflow state as well. So I'm gonna add the security findings here in the workflow state file. I also need to update the workflow order in the agents file. I already did that. I added a new step to the workflow order. I just need to update the numbers here. And I add the security reviewer to planner task. This is important because then planner will have access to execute or run this sub agent whenever it's needed. Now let's run the whole thing. I will give the planner a feature request, and we will watch the workflow play out end to end, from clarification through security review and final commit message. The planner doesn't immediately start coding. It asks clarifying questions. Watch how workflow states getting updated. And then debater runs next. Watch what it writes under debate nodes. And then the planner writes the clarify the scope and everything in place, updated the plan based on the debater nodes. And the workflow seems to be working. Notice what just happened. Workflow state file is now a complete audit trail of this entire feature. Every decision, every handoff, the security finding and its fix, the test result, and everything. If something breaks in 3 weeks, I can open this file and reconstruct exactly what happened. The traceability is something you just don't get from a single agent setup. 3 layers. Ollama gives you the model layer. Private, free, and flexible. OpenCode gives you the agent layer. The specialized roles, permissions, share the state. Serena and the security review extend both. Better code understanding, automated security audits without changing anything else about the workflow. The design principle is the same: narrow agents, clear handoff, and nothing writes code except the implementor. That's the full workflow. Ollama for local and cloud models, OpenCode for the agent structure, Serena as a semantic code assistant, and the security reviewer that audit every change. All on your machine, no API key required. If you try this setup in your own repo, tell me in the comments. What model did you use for the planner? Did Serena make a real difference for your project? What did you change for your own stack? I genuinely read those comments and they shape what I build next. And I want to ask you something directly. In the next video, I want to implement the same workflow with GitHub Copilot CLI, and then comparing GitHub Copilot CLI with OpenCode. Both have agentic workflows. Both support custom agents. Both work with local models. But they have very different design philosophies. I want to do an honest side-by-side, and I want to focus on what actually matters to you. So 2 questions. 1. What tools are you using for agentic AI development? GitHub Copilot, OpenCode, Cloud Code, Cursor, Hermes, or something else? 2. What do you want me to focus on in that comparison? Performance, privacy, setup complexity, cost, or feature gaps? Write it below. I will read everything before I record that video. If this was useful, subscribe so you don't miss that comparison. The full config files and all agent markdown files are linked in the description. Thanks for watching. See you in the next one.